Very good morning to one and all. Let us see the subject 21 ES 101T Electrical and Electronics Engineering. Unit number 1. The unit number 1 we can divide into two parts. One is DC circuits and another one is AC circuits. The DC circuits deals with Ohm's laws and Kirchhoff's voltage law, Kirchhoff's current law, mesh analysis, nodal analysis, and some of the theorems like Thevenin's theorem, maximum power transfer theorem, and superposition theorem. The second part, that is AC circuit, deals with the basic terminologies of alternating currents, that is AC alternating circuits. Root mean square RMS and average value of half wave and full wave alternating quantities. Fundamentals of single phase AC circuits. Analysis of RL, RC and RLC combinations series circuits. And fundamentals of three-phase AC systems. Three-phase winding connections, relation between line and phase voltages and line current and phase currents. Of course, the star to delta and delta to star conversion techniques. There will be some practices on the theorems of wave and full wave bridge rectifier circuits. So the basic SI units, you might have been familiar with this. The length, mass, time, as well the multipliers, 10 to the power of plus 12 and plus 9 plus 6 plus 3 plus 2 plus 1. These terms called as tera, giga, mega, kilo, hectare, deca. In the same way, 1 upon 10, 1 upon 100, that is 10 to the power of minus 1, 10 to the power of minus 2, and so on, 10 to the power of minus 12 is called as deci, centi, milli, and micro, nano, pico. In this slide, let us see the fundamental unit of charge is called as coulomb. A single electron has a charge of minus 1.602 10 to the power of minus 19 coulomb. This means that the total charge, that is 6.24 10 to the power of 18 number of electrons in 1 coulomb. Because a single electron having 1.602 to the power of minus 19. So 6.24 to the power of 18 number of electrons in 1 coulomb. As you might have studied in basic physics, the current of 1 ampere is said to flow of 6.24 to the power of 18 number of electrons. What is current? The number of electrons passing through a conductor in a second. The conventional to take the direction of the current flow opposite to the direction of the electron flow. Mathematically, the current I, you can write it as dq by dt. dq, that is q, you can write it as I into dt. So 1 ampere is nothing but 1 coulomb per second. Similarly, 1 volt. Volt usually we refer as potential difference between 2 points. Current always flows from higher potential to lower potential. 1 volt is equal to 1 joule per 1 coulomb. So the power P, you can write it as dW by T dt. Work done at a particular time. This you can rewrite as dW by dQ into dQ by dt. dQ by dt, we know that it is I. dW by dQ is nothing but volt. That is here. 1 volt is equal to 1 joule per coulomb. So thus we can write it as the DC power P, we can write it as voltage into current. Right? So now let us see the energy. What is energy? Energy is nothing but power into time. Power unit is watts, time unit is seconds. So power into power into time, you can refer as energy, that is measured with the joules. If a device consumes 1 watt for 1 second, then the energy consumed is 1 joule. The electric power utility company measures the energy in kilowatt hour. So forget about the K. WH, what is the unit for W? So power unit is W. Hour, it is time. So power into time is called as energy. That energy is represented with kilowatt hour. 1 kilowatt hour is 3620 to the power of 3 joules. Right? Kilowatt hour. 1 kilowatt hour, the electrical terminology is called as 1 unit. The number of electrons which constitute a charge of 4.005 into 10 to the power minus 16 coulomb. The charge in one electron is 1.602 to the power minus 19 coulomb. So if you find the number of electrons which constitute the charge of 4.005 into the power minus 16, it's very simple. It will be 2500. So you must be very clear in the relations between time and current, power and energy, and charge and electrons. So with these conversions, you may have some MCQ in your test as well as in your university questions. Look at the direct current circuit and alternating current circuit, that is DC as well as AC. DC is called as direct current circuits, AC is called as alternating current circuits. The DC elements like voltage source, either this way or in this way, you can represent in the circuits as the current source. In the same way, this can be represented in this way also, opposite. So this positive plate is called as plus and negative plate is called as minus. It is understood. This is the resistance is represented with this symbol, the resistor. Voltage source of AC, current source again of AC. Resistor, inductor, capacitor is represented with these symbols. Let us see the various type of sources. What are the various type of sources? We are having dependent source as well as independent source. In addition to that, you can distinguish into ideal source as well practical source. What is the difference between ideal and practical sources? Ideal source is one in which the internal resistance will be zero. For example, if you take a voltage source, definitely there will be some internal resistance. If the internal resistance is zero or negligible, you can call it as ideal source. In the practical sources, definitely there will be some internal resistance. Practical voltage source example is battery cell. Dependent source, independent source. Normal pentorch battery you would have seen. This independent source or dependent source? It is independent source, independent voltage source. In fact, independent DC voltage source. The dependent sources again you can classify into AC as well as DC. Sorry, independent sources you can classify into AC as well as DC. The AC further you can classify into single phase as well three phase. Ideal sources, DC voltage source and DC current source is shown in figure. This is known as ideal voltage source because there is no internal resistance. If it is a practical voltage source, there will be an internal resistance here, right? Here there will be an internal resistance. So this is the terminal voltage plus minus. As it is ideal voltage, so the same voltage you will be getting here. If it is practical voltage source, this voltage, some of the voltage portion will be dropped here. The remaining voltage will be getting as terminal voltage, right? Fine. This is the representation. In the same way, this is a current source. If it is a practical current source, there will be internal resistance like this, right? As this resistance is open, that is infinite, it is called as ideal voltage source. This one is practical current source. If you remove or if you open this one, in other words, if the resistance value is infinite, then this will become a ideal current source. This is a graph for ideal current source. So dependent sources is nothing but four categories are there. One is voltage controlled voltage source, current controlled voltage source, current controlled current source, voltage controlled current source. These are all the four different combinations for dependent sources. This one is, look at this symbol, this diamond symbol represent, it belongs to dependent source. This plus minus represent, it is a voltage source. This arrow mark represent, it is a current source, right? So what is this? This symbol represent, it is a dependent source. This plus minus, if you find, it is called as voltage source. So it depends on some other branch voltage. So you can call it as voltage dependent voltage source, right? This one again, the symbol dependent source, this plus minus represent, it is a voltage source, dependent voltage source. It depends on what? Some branch current, right? So you can call this source as current dependent voltage source. Fine. This one, this symbol represent, it is a dependent source. This arrow mark either upwards or downwards represent, it is a current source. What is the meaning of phi I naught? This source depends on some other branch current I naught. So you can call it as current dependent current source. What about this one? Again, this symbol, diamond symbol represent, it belongs to a dependent source. Again, this arrow mark says that it is a current source. It depends on the magnitude 4 V0. It means that this dependent current source dependent on some other branch voltage V0 into 4 times of V0. So you can call this one as voltage dependent current source. That's all. This is the way in which you have to represent. We will see some of the as you are doing the basic course, that is electrical and electronics engineering, so we won't have much difficulties in problems. Like in fact we can have the problems with circuits with the dependent sources, but mostly you will be getting only with the DC sources in the first half. In the first half, simple circuits only will be having in your questions. You need not worry about. However, you must know what are all the various kinds of sources, right? Now let us see the following units: voltage, current, resistance, and conductances. Voltage, usually it is a potential difference. Higher potential to lower potential, the current flows. When there is same potential, current will not flow. Current always flows from higher potential to lower potential. The unit is volt, current, ampere. Number of electrons, flow of electrons, it's called as current. That is measured with the help of ammeter. The unit is ampere. Resistance, of course, it is ohm. Conductance is reciprocal of resistance, it is mho, or you can call it as Siemens. Ohm's law. Some of you might have familiar with these laws in your 12th standard, the same Ohm's law and Kirchhoff's voltage law, Kirchhoff's current law. Ohm's law, when you state the Ohm's law, you must remember that Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided, this is very important, all physical condition and temperature remains constant because we are having two different temperature. One is positive temperature coefficient, another one is negative temperature coefficient. So we are keeping the temperature as constant, all other physical conditions as constant, then we are applying the Ohm's law. So here, this is the potential V, and there is voltage drop across this resistance is V plus minus. This is the current flowing direction. So whenever a current flowing through a resistance, it makes the voltage drop, that is voltage V plus minus. This is the entry, right? Entry point is plus and minus. Right? So for a resistance, whenever the current flows through a resistance, I into R is nothing but voltage. The voltage drop will be there. The polarity of this voltage drop plus minus based on the current direction. If it enters in this way, here it is plus, here it is minus. The same current enters here, so this side is plus, this side is minus. So based on the current entry direction, the voltage drop differs. This you must remember, right? So the resistance of a conductor is directly proportional to its length, inversely proportional to its area of cross section. It also depends on the material of the conductor. So what is R? R is nothing but rho L by A. Rho is nothing but the resistivity of the material. L is nothing but the length of the conductor, and A is nothing but the area of the cross section. So the A, we are assuming that the entire length of this conductor area of cross section should be same. Assume that a 1 meter wire in the initial side, the diameter, the area of cross section is one value. In the other end, if it is different, so this Ohm's law is not applicable. So we are assuming that the area of cross section should be the same. In that case, if you want to calculate the resistance, you have to integrate each and every part, right? So for normal cases, let us assume that the area of cross section is same. R is equal to rho L by A. So we know that power P is equal to V into I. So if you substitute the value of V as I into R, you will be getting power P is equal to I squared R. This is another way. In the same way, if you substitute I is equal to V by R, you will be getting V squared by R. So in any one of these ways, you can represent the power P is equal to V into I squared into R, or V squared by R. All are one and the same. I of T is equal to 0, G is equal to 0, R is equal to infinite. What is this? When current is 0, it means that it is an open circuit. That is, resistance R is infinite and the conductance is 0 because the conductance G is nothing but reciprocal of this resistance. So if it is infinite, this conductance should be 0. In the same way, the voltage is 0. It means that the resistance is 0, right? And G is equal to infinite. So this is open, this is short. When voltage is 0, this is short. In the short circuit, R is equal to 0. Resistance is 0. So conductance will be infinite. So this is a simple problem, a numeric problem. An electric kettle draws 5 ampere at 200 volt. Find its resistance. So using Ohm's law, we know that V is equal to I into R. So R is equal to V by I. We know the value of voltage as well as current. So we can easily calculate the value of the resistance. It is 40 ohm. In the same way, a voltage is 60 volt is applied across a resistor of 2.5 kilo ohm. Determine the current I, conductance G, and power P. So very simple problem. So using the Ohm's law, V is equal to I into R, and power P is equal to V into I. Easily you can calculate that. Very good morning. Let us see the Kirchhoff's laws. There are two laws are there in the Kirchhoff's. One is Kirchhoff's current law, another one is Kirchhoff's voltage law. What is Kirchhoff's current law? Kirchhoff's current law says that the algebraic sum of the current at a node is equal to 0. In other words, entering current at a node is equal to leaving current from that node. In the same way, Kirchhoff's voltage law says that the algebraic summation of voltages in any closed path is equal to 0. In other words, you can explain the same KVL as voltage rise equal to voltage drop. To understand this, let us take this simple circuit in which at this point P, Two currents are entering I3, I2. Two currents are leaving I1, I4. So as per Kirchhoff's current law, entering current is equal to leaving current. So I3 plus I2 is equal to I1 plus I4. That's all. This is Kirchhoff's current law, KCL. The right side, look at the circuit in which these are all node. This is one node. More than two branches meeting at a point, you can call it as a node. This is one branch, this is another branch, this is another branch. So three branches meeting at this point, you can call it as a node. This is a node. This is a node. All four branches are meeting at this point. This you can call it as a node. So each and every node you can apply Kirchhoff's current law. Entering current is equal to leaving current, right? So with that we can easily calculate the unknowns. That is current flowing through this branch is called as I1, I2, I3, I4. Easily you can calculate because at this node these two are entering 7 plus 3. This one is leaving. So I1 should be of addition of these two current. So in the same way, you can calculate the other three unknowns easily. Yes, now let us see Kirchhoff's voltage law. As I said, Kirchhoff's voltage law is nothing but the algebraic sum of voltages in any closed path is equal to 0. Let us take the simple circuit in which one voltage source 10 is connected, DC voltage source 10 is connected in series with the 2 ohm and 3 ohm. The voltage drop in the 2 ohm is 4 volt. Voltage drop in the 3 ohm is 6 volt. The value of current I is equal to V by R. What is V? As per Ohm's law, I is equal to V by R. The voltage given is 10. 10 divided by addition of these two because these two are connected in series, right? So 2 ohm and 3 ohm are connected in series. In the series branch, you can add the resistances. 2 ohm plus 3 ohm is equal to 5 ohm. So the current flowing through this mesh is nothing but 2 ampere. So whenever current enters into this branch, this marks the polarity plus and minus. So in the 2 ohm branch, the voltage drop is current into the resistance, that is 4 volt. Again, the same current is flowing through this. That is the beauty of the series cycle. Though the resistance values are different, the current flow must be same, right? The same 2 ampere is flowing here. The 2 into 3 is 6 volt. So entry side current is plus, the leaving side is minus. So look at the polarity. Here it is plus, here it is minus. Different polarity means you can add the voltages. That is a thumb rule. So here these two addition of these two voltages is 10 volt. The voltage rise is 10. So voltage drop is 10. So 10, 10 both gets equal and it is 0. Voltage rise equal to voltage drop. In other words, addition of the voltages in any closed path is equal to 0. Right? In the same way, you can calculate the voltage in these three branches. Right? V1, V2, V3 easily you can calculate. How? Same way, I is equal to V by R. Voltage V is equal to 50. Resistance is equal to 2 plus 3 plus 5. How much will come? 10. So 50 by 10 is equal to 5 by 1 is equal to 5. So the current flowing through this is 5 ampere. So 5 into 2 is here 10 volt. Here 5 into 3 is 15 volt plus minus. Here it is plus minus because entry side is plus, leaving side is minus. Here also entry side is plus, leaving side is minus. Here also entry side is plus, leaving side is minus. 5 into 5, 25. So how much is coming? 10, 25, again plus 25, 50. So 50 is equal to 50. So this is called Kirchhoff's voltage law. Algebraic sum of the voltage in a closed path is equal to 0. Okay. Now let us see the simple cycle to realize the Kirchhoff's voltage law. Here, look at the unknowns. V3, V1, V2, V4. These four are unknowns. With the known values of these two branch voltages, the unknown value easily you can calculate. Algebraic summation of the voltage in any closed path is equal to 0, right? Fine. Here, this branch voltage drop is 7. This voltage drop in this branch is 3. This is unknown. So minus 7 plus 3 plus V3 is equal to 0. Why minus 7? Look at this. This minus and minus is connected. Then I said algebraic summation of the voltage any closed paths is equal to 0, right? So when you are adding, look at the polarity. Minus minus means you have to take the difference, same polarity, whether it is minus minus or plus plus, you have to take the difference. When there is different polarity, whether it is plus and minus or minus and plus, you can add it. That is the thumb rule for adding voltages. So in this way, you can easily calculate V1, V2, V3, V4. Fine, we will meet in the next. Thank you.